Welcome, everybody, to the October Wildlife Society monthly webinar series. I'm John Bryan. I'm the current chair of the Wildlife Diseases Working Group, who coincidentally are also the sponsor of today's webinar. We've got a lot of exciting stuff coming up, and so I'll have a couple of ground rules to share with you off the bat. The first is that we're going to hold all questions until the end. However, if you do have somewhat of a burning desire, feel free to pose those questions in the Q&A, and we'll get to them as best we can toward the end of the presentation. All right, so with that, I'm going to go ahead and introduce our speaker today, Dr. Marc Valitutto, who is from the EcoHealth Alliance. Dr. Valitutto received his veterinary degree from the University of Pennsylvania in 2006. In 2011, he completed a residency at the Wildlife Conservation Society and since has conducted field work with the Smithsonian, mainly for the PREDICT project in Myanmar and Kenya, in addition to about 1.5 years doing giant panda work in Chengdu, please forgive my mispronunciation, and pangolin clinical health studies in Vietnam. In 2020, he began working with EcoHealth Alliance projects focused on emerging infectious disease investigation, primarily with a focus on disease vectors, and with additional focus on technical skill building for field teams, animal welfare optimization, and advancing field biosafety standards. Dr. Valitutto's EHE work, meaning EcoHealth Alliance work, continues throughout the world currently. For example, in Africa, South Asia, Southeast Asia, and South America. So without further ado, I present to you Dr. Marc Valitutto. Take it away.
Thank you, John. I'm really excited to be able to speak to the Wildlife Society. I have some exciting new prospects in field biosafety. I happen to actually also be at a biosafety conference at the moment in Omaha, so it's very timely. So let me share my screen. Okay. John, can you see that okay?
Looks good.
Yeah, I can see it just fine.
Thank you. So again, if anyone has any questions, hopefully we could save those to the end. But if you have a burning question, you're absolutely welcome to add it to the chat. And John, you can help facilitate me answering that right away. Okay. So again, as I mentioned, I'm really excited to be able to talk to you about this. This is a story about the development of a field biosafety manual. I hope it's not too boring. I'll try to keep it fairly exciting. So as everybody knows, the last 3 years has been quite difficult for everyone in every field. With the COVID pandemic, there's been a lot of chatter about the work that's being conducted in the field, specifically scientists that are out there trying to look for the sources of pandemics, nicknamed virus hunters. And so with this media attention, there's actually been a big call to end all of the work being conducted because of the risk of contracting a disease. Potentially, this is the source of the next pandemic, which is specifically what we're trying to prevent as virus hunters per se. But the media personnel, they really are considering that maybe we should end this altogether because it's just too risky. Even as recent as April, this is the Washington Post put together a very in-depth report about the work that's being conducted all over the world to investigate where these diseases are coming from and what it means. They went so far as to dissecting every area where an individual who's doing this kind of work can contract or be at risk for a spillover event. So you could just see this is just a nice, from the start, from going into a bat cave, working with the bats, sampling the animals, and then, processing the samples thereafter. Even more recently, also in April, report from the Energy and Commerce Committee with Congress. There's been a big push with their congressmen at the House and the Senate who are very concerned about the work that's being conducted, also being the source of the next pandemic. So I'm sure some of you are quite familiar with USAID projects that are funded by the US government, fairly heavy price tags, maybe $100 million for stop spillover, $100 million for deep vision, and then various other projects with the Department of Defense, NIH, et cetera, all trying to fund this disease investigation in the wild, while also pairing that with disease investigation with people who are at these interfaces, and then building up laboratory capacity, et cetera. So the Energy and Commerce Committee specifically is concerned about the biosafety conditions that the people are going out there and the practices that they're following and the risk that it has for them to contract these diseases. So it's not just the journalists, it is the very lawmakers that govern our society. So then a little bit further down in May, we have further questions, the U.S. right to know. They are very big in trying to understand all of the funding that is coming from the United States government to fund the different projects that we're doing in the field and for all of these disease investigations. Some of the things that they were reporting back is the concern about what kind of PPE people are wearing when they're conducting these kinds of activities. And already just this very little excerpt that I pulled out here, you could see there's the difference in what people want to wear, whether it's Tyvek suits, whether it's something less, maybe the Tyvek suits are what is actually the problem. Do we need to wear gloves? Is that going to be an issue when we're in hot and humid areas? And I think all of you who are on this webinar are also asking those very same questions because I'm sure you've all had to deal with them yourselves. So specifically for One Health researchers, there has been a transition over the last 10 years or so from wearing very simple PPE to realizing the risk that is at hand and the need to be wearing much more stringent and protective gear, depending on what it is that you're doing. But there is no consistency. It varies with every group. There is no overarching guideline that says you need to be wearing this when you're working with this species. You need to be working with wearing this when you're working in this environment. And you can see here, this is just a nice little dissection of people doing One Health research, and each one of them wearing a different level of PPE. You could see, some of the standards that are out there now really are suggesting that you need to be covering your mucous membranes and then the skin that is most exposed. And so you could see on the left photo, we have no mucous membranes really covered. And then in the middle photo, they're wearing a full Tyvek suit, but they're also wearing a surgical mask and not an N95 that, we all know is the best for particulate filtration, but also his wrists are exposed, his eyes are exposed. And then you have the following on the right, which is full Tyvek suits and an elastomeric respirator. And then there's no consistency across disciplines. So beyond the One Health researchers, beyond the virus hunters, what if you're a veterinarian who's just doing clinical work? What if you're an ecotourist? Are you expected to be wearing Tyvek suits? What if you're a pathologist or doing disease investigations for mortality events with animals that maybe aren't consistently concerned about being a vector for various emerging infectious diseases? So clearly there's a need for standardization, especially with all of this inconsistency within One Health field and then outside of anyone who's doing work with animals or in their environments. But where do we begin? I'm sure many of you have asked the very same question. It's nearly impossible to standardize a field, an area, wild areas that are completely unstandardizable. There are far too many hazards. And so something like this, the standards that we want to consider have just really not been approached. And that's why they've really only stayed focused on each individual institution or organization based on what they perceive as the risk to their people. So where again do we begin? Who is our target audience? So we started with asking a few questions. Who is our target audience? What are the current resources? What's missing? And what exactly should we be providing? And so beyond the One Health researchers, beyond the people doing the virus hunting, I already mentioned several other careers or interfaces that people have with animals or environments of concern. What if you're a biologist? What if you're an ecologist or an epidemiologist? What if you're a paleontologist or a botanist, for that matter? And then various other careers or lifestyle situations. You're working with these animals, and you're even a developer, who has nothing to do with the animals, but you just want to work on the land. And so it just brings you back to that very first slide that I brought up, which is the media saying that we need to discontinue all of the work with these bats or all of the work with these vector species because it's the source of a next pandemic. But how do we stop or restrict all of these other careers or lifestyles that also have equal or even more interfaces with these animals of concern? You can't. And so there really is a need to understand what is the actual risk and what kind of provisions or guidelines that can be provided. So just a few more. I really got a little carried away with those pictures. All right. So who again is our target audience? This is our first question that we needed to answer. So it's literally everything I just said. It's everyone who's conducting research activities at the interface with free-ranging animals. It doesn't have to be One Health researchers. It could be botanists. It could be any scientific discipline. But also anyone who is working in these areas, any occupation beyond scientific disciplines. So developers, landscapers, etc. And then anyone who is working with captive animals. So this is a little bit of a stretch because it's not animals that are exactly in a wild setting, but we have a lot of animals that are captive. In the US, we have a lot of animals that are captive, but most of those animals are evaluated by veterinarians, or their health is guided by veterinarians. But in a lot of nations, developing nations specifically, there are animals that are bred for food. So wild captive animals that are all in farms for a different aspect of resources as opposed to the standard livestock. But then you also have animals that are in markets that are just brought in from the wild, interacting with each other, and then sent off for just a nice meal. So further, we have other people who are living amongst these animals, and then finally, people who are conducting activities in just the environments, maybe not necessarily with animals per se, or even animals that are around. Okay, so what are the current resources? So there's obviously several. WHO, CDC are our biggest ones that have put out the most information for trying to standardize this kind of work, but really only focus on the people who are responding to outbreaks, or working in areas that are known to be of major concern for high risk of emerging infectious diseases. But then you have others, FAO, NIH, OSHA, EPA, etc., including also universities with their own IACUCs and institutional biosafety committees. U.S. National Park Service, the USGS, has done a lot of work as well, especially for U.S.-based wildlife. So, just again, these are the other areas. These are another summary of the kinds of stuff that's out there for providing guidance specifically with wild animals. Myself, I've worked with USAID on the PREDICT project, and that's where we really had the largest impact on creating biosafety standards all across the project, about 32 different nations that are collecting samples from various different wildlife species, especially vectors. And it really put out the most comprehensive work across the globe for guidance on biosafety, specifically mostly about PPE. Okay. What's missing? So field guidance that recognizes the nuances of the various field situations. So that's just another thing that I had mentioned earlier on already, which is basically there are far too many variables that would allow us to provide some standards. And we recognize that. And so we've been looking at that and trying to figure out, is there a way around all of the different variables that we're presented with? We're also missing basic guidance for field teams and the investigators. So you are all aware that there are scientific investigators throughout the world, but each investigator has a different level of experience doing this kind of work. whether they're a PI that is focused on working specifically with animals that have a long experience, or this is their very first time and they've been awarded a major grant, or they're someone who is a co-investigator who is working under a PI who has a lot of experience, but the co-investigator has no experience and they're left on their own to really figure it out. But then you have your field team. Some of your field teams are amazing. They're well versed in the work. They have been well trained. They have various levels of degrees and experience in education. But then you also have field teams that have very minimal education. Oftentimes, they do not share your language when you're trying to conduct the activities. Some of them are people who are volunteers or people that you just identified from the local community to be able to conduct this work. And also people with different priorities on what exactly is safety, because perhaps they've lived amongst these animals their entire lives and never had to wear any form of safety or practice any form of safety. So as I mentioned already, there's no directions on the appropriate PPE materials, how to source them, what is the thickness, what are the things that we need to be thinking about with the different situations, and then the decontamination and waste management, especially given the different areas that you're going to be in, the impacts on the environment, the impacts on the wildlife, and the impacts on the local community. So, and then of course, there's no standards for training. There's no standards to begin with, so there's no standards for training. Okay. So now this brings me to the Field Biosafety Manual. This is something that we have now been developing for the last 3 years. Of course, in direct response to the COVID pandemic. But in reality, I was asked to take on this project just to develop our guidelines or enhance the guidelines that we have been using for the PREDICT project, the USIAD PREDICT project. And so it really was only supposed to be this 15, 20-page document that was just going to be fixed up and ensure that we were prepared for the next project that we were working on. But with the repeated media attention that was pummeling anyone who is doing this kind of work and really invalidating the work, recognizing that it's very unsafe to do it, it put an impetus under us to be able to create something that was far more robust. And while preparing the updates, we realized there were so many more questions that needed to be answered. The PREDICT's work, the USGA's guidelines that were prepared were fantastic. But throughout the world, applying these throughout the world, there are far more questions that still needed to be answered and to be able to respond to or target the various audiences that I had already mentioned. So we started developing the Field Biosafety Manual, which now stands at about 400 pages and continues to grow as we bring in more authors and chapters that we're trying to get in there and creating the look and feel to ensure that it is readable or acceptable for people of various different education levels and interests. So it was designed after 2 very obviously well-known manuals on biosafety, specifically the CDC's BMBL, which guides the, at least for US institutions and various other institutions throughout the world, on what kind of biosafety levels and practices should be maintained at the various laboratories, depending on the risks of the materials or the pathogens that you're working with. And then, of course, it's the WHO's Lab Biosafety Manual, which is not competitive to the CDC, but provides an alternative plan of practices for each lab to be able to conduct their work. The difference is, at least from my knowledge, the CDC's BMBL really provides that framework that labs really are looking for to be able to conduct their activities, whereas the WHO relies much more heavily on risk assessment for each lab to be able to put forward what kind of practices they should be following. Okay, so I will very briefly go over a few things, including the contents of this manual. As it stands right now, we have about 7 different chapters, including hazard identification, risk assessment, specifically field biosafety levels, which I will get into, risk mitigation protocols, which is the bread and butter and the type of practices that should be followed and how to follow them. And then, of course, emergency response and exposure. I do want to point out and remind everyone, the development of this manual is a combination of both the CDC's BMBL and WHO. We really do heavily rely on being able to provide everyone with guidance, but at the same time, we want people to be able to calculate their own risks. And this again is largely due to the fact that the environment is full of surprises. There is just not enough books out there to be able to identify every single risk that or hazard that can be presented to anyone working in the field. But there are a lot of common denominators that we can address. All right. So very quick, the introduction carries a few very simple introductory pieces of information. But then, of course, is hazard identification. We go into great depth identifying all of the different types of hazards that can be posed in various situations, whether or not you work in an ocean, if you work in Antarctica, you work in a human environment, you work in a desert, it doesn't matter. We're trying to identify all of the different types of hazards that can be presented to an individual working in the field. And of course, everyone is far aware of these. These are just examples, the tables that we've included, and it's not exhaustive, but it definitely provides people with the most common ones. So that way, when they are reviewing the book and developing their own protocols or selecting their protocols from the book, they're reminded and saying, oh, I should think about this. What exactly is the concern about toxic plants where I'm going to be? Is this going to be a big deal? Are there venomous snakes? Even though I'm looking for viruses, are there venomous snakes that I'm going to be walking into that is going to limit the amount of work that can actually be done? Your physical hazards, of course, we're all very well of these terrain hazards, environmental hazards, if you will, safety hazards with the actual work, the different products that you're using, chemical hazards, also depending on the products that you're using, and which will obviously differ with your scientific discipline. The ergonomic hazards, I think everyone is well aware of these as well. OSHA is very good at providing information on this. And then your psychosocial hazards. This is something that maybe is a little oft overlooked, but of course, definitely impacts the work that's been done, the stress that you might have, the interaction that you might have with each other that might cause mistakes. And all of these need to be identified right prior to starting any of your field activities. Okay. And then, of course, is your risk assessment. This is one of the chapters that we're actively trying to make much more robust and make it so that way everyone is able to conduct their own risk assessments without being overly complicated about it, and trying to conduct risk assessments for basically every kind of thing that you might want to consider, whether it is the actual virus potential, the pandemic potential, or the traumatic potential. You know, anything that we can think of, we really want people to be able to understand how to assess their own risk. I think this is probably the most important aspect of the manual itself. Okay, so on that note of evaluating risk or doing risk assessments, many of you are already aware of the microorganism risk groups that are put out by WHO and NIH. And so you can see here, this is the definitions based on risk group 1, 2, 3, and 4 with example viruses, bacteria, and other types of pathogens. The definitions would be, for instance, risk group 1 is low individual risk, low community risk, or from NIH, it says unlikely to cause human or animal disease. Whereas on the opposite end, we have risk group 4, which is high individual risk, high community risk, and very serious diseases that are readily transmitted for which there is no effective treatment available. Examples of these would be Ebola, Marburg, Congo hemorrhagic fever, things like that. I'm sure all of you guys are very much aware of. So, in the laboratories, when we're practicing or working with any of these pathogens, we follow a similar nomenclature with the level of biosafety that needs to be maintained. 1, 2, 3, and 4. So BSL stands for biosafety level. ABSL stands for animal biosafety level. So when you have animals in a laboratory. And what I have here is an overly simplified correlation between risk group and biosafety levels. So you see risk group 1 correlates to biosafety level 1 that needs to be practiced. But there are so many nuances in here and risks that have been reevaluated regardless of the risk group that a pathogen is put in. Sometimes a pathogen can be practiced on in a lower biosafety level, and sometimes at a higher, depending on the type of work that's being conducted with that pathogen and the risk of exposure or contractibility of that pathogen into the human. So it's not just as easy of a correlation as put here, but for the purposes of this conversation, we're just going to say that. So those are the risk groups that are created by WHO and NIH. There are no further risk groups when we're working in the environment. How, when we go to the environment, do we know what is the pathogen risk? We don't always. We do know in some areas there's a higher likelihood of Ebola or Marburg that is happening. Maybe when there's heavy rainfall, we know that there's a higher chance of cholera or malaria because of the mosquito load. Different seasons call for different diseases coming out there. Maybe in the springtime or fall, we have a higher West Nile virus caseload in the US. But if you are conducting your field activities and any discipline, whether it's One Health, whether it's virus hunting or ecology or taxonomy, how do we know what kind of protection we need to wear? We have bat ecologists contacting us who are not looking for diseases, but they need to know what it is that they need to protect themselves. Because they're also taking blood, they're also taking samples, but they're not looking for anything except for genetics of the species that they're working with. So based on the literature that's out there right now, published by some of my colleagues in EcoHealth, we're able to actually create different risk groups for different species, some of which all of you are quite aware of as well. And so if we delineate these out, we can create risk group labels. Just like with the risk group labels for the microorganisms, we created risk group labels for animal groupings based on taxa. So you see risk group level 1 are your invertebrates and your lower vertebrates. Risk group 2 would be your higher vertebrates, namely mammals and birds. Risk group 3 are your vector species that typically are responsible for sharing most of the emerging infectious diseases that we see in humans today. And that would be rodents, primates, and bats, of course. And you're probably asking, hello, there are animals that are in your risk group level 2 that carry highly deadly diseases that are classified as a microorganism risk group 4. How in the world are we accounting for that? The reality is that any one of these species, whether it's risk group 1 or 3, any one of these species can become a risk group category 4. And we know this for sure because we have examples of this as currently. And so you all know avian influenza from waterfowl, MERS from camels, and of course, bats that are carrying Ebola. So the hope and goal here is to recognize if you have a identified pathogen that you know is coming from these species, then probably you should be practicing a higher level of biosafety when working with those. But if you are working with camels in, say, the Middle East versus camels in your zoo or camels in Australia that have not had any MERS, then maybe you don't need to practice the same levels of biosafety. But if it's a relatively unknown situation, we are providing guidance based on the risk groups that we've created here. Similarly, so we have environmental risk groups. So sometimes there's just no animals there. Maybe you're not working with animals at all, and there's no chance of animal even occurring in that location. But there is a risk for these pathogens, these microorganisms, for persisting in the environment, whether that is from a vector insect species, arthropod species, or that is just a pathogen is sitting out in the environment. Maybe it's on a surface. Maybe you're going down into a mine or a cave with no animals in it, but it still has a high risk of a pathogen just persisting in the air or on the surfaces, as I said. And just like with the animal risk groups, any one of these environments that have been identified as low, medium, or high risk can change at the drop of a hat. We all know climate changes, seasonal changes, landslides, or any major natural disaster can completely and very quickly change the risk for these environments. I did want to mention that these risk groups that I'm creating here are specifically for pathogen risks and not for anything else like terrain risks or traumatic risks. It's all specifically about pathogen. Okay. All right. So coming here with our animal risk groups and overlaying that onto our microorganism risk group chart, we were able to create a little bit of a correlation with biosafety and animal safety levels, but it's not exact. There's applying the biosafety levels from laboratories, whether that's animal biosafety level or biosafety level in general, just does not work for when we are working in the field, especially when we are working with unknown situations. So it's not applicable. So what do we do? So let's just rewind a little bit and look quickly about what we have in a lab. So in a lab, we have a building, we have an outdoor environment, and we also have our inner laboratory within a building. And then you have different jobs that are happening. Inside that lab, you have one pathogen. Let's say it is a microorganism risk group 3 pathogen. We're practicing biosafety level 3 inside. Outdoors, you have different people. You have a trucker. You have people that are bringing the products to your building. You have people just in the environment that are living out there because they live there. You have office workers that work inside the building, but they don't go inside the laboratory. But then you have your scientists, the only ones who are really permitted to enter these labs. I did include people who are cleaning, but we also have the scientists that are doing the cleaning inside these biorisk or BSL level 3. But lower level biosafety levels, say if you're working in a high school laboratory, you do have other people that are coming in and doing the cleaning. Okay. In the environment, we don't have that building. We don't have that inner lab. So where do we draw the line on protection? Now we are no longer just protecting the scientist. We are now exposed to everybody. So in my experience, it has been fairly arbitrary. So you have the scientist that is working with the microorganism risk groups, but in our environment, say we don't know what the risk is. So we're looking at an animal and we've applied animal risk group 3. Let's say it's a bat, and or an environmental risk group that we're working in. And as I said, everyone now is exposed. There is no lab. There's no building to protect you. There's no HEPA filters to protect you and the environment. And so the line has been fairly arbitrary. And usually it's only for the protection of the individuals directly doing the work, with nothing for protecting anyone else. So this is where we have decided or created something novel, the FBSL, or the Field Biosafety Levels. And it really does borrow the guidance that is provided for biosafety levels developed for labs, but with so much changes that make it far more hospitable for working in the field. So it's a far more dynamic set of guidances. It follows the same rules that standard biosafety practices follow, including the hierarchy of hazard controls, which if you don't know it, I'll get into it. We evaluate and rely on the hazards identified in the field. We develop our own risk groups on animals and the environment, and we pair that with the likelihood of exposure for the level of biosafety that needs to be practiced. So this is just a very simple correlation. And of course, like I mentioned, with biosafety levels on the lab, not necessarily correlating directly to microorganism risk groups 1, 2, 3, and 4. The same thing for field biosafety levels and the animal and the environmental risk groups. Okay, so I'll move on from this. This is the hierarchy of hazard controls. Some of you may be familiar with, some of you not, but it basically just shows the level of importance of protections that need to be put in place and which ones are the most effective versus the least effective for protection. And so you can see at the very top, elimination, take the hazard away. Of course, that's going to be the most effective. Essentially, don't do the problem. Don't put yourself in the situation and you won't have the issue, versus all the way down to the bottom, which is PPE. And for the most part, for the very work that we're doing, we can't eliminate ourselves from the equation to do this kind of work. And so we have to protect ourselves with PPE. But all of the things above it, they're the far more important to be conducted. All right, so field biosafety levels. This is a very summarized chart and far less in depth than what is actually written in the chapters of the manual, but it just provides you with a little bit of detail that you can see about the types of things that are different based on each biosafety level. And so you could see we have different examples of agents or pathogens that you can consider, or also, of course, the animal risk groups. But then you have different directions on how your field site is going to be designed, the levels of occupational health that need to be considered, the types of people that should be working, the supervision and the management team that needs to be put in place, the levels of decontamination and waste management, and of course, the levels of personal protection. So this is just scratching the surface here of what's been written, and we can answer any questions at the end if should you have it. But you can also understand that clearly FBSL 1, which might be working with frogs, you're practicing or you're teaching students, 8th grade high school level students, how to do a research project with frogs in the wild, simple, or catching tadpoles. There's very simple levels of protection that need to provide it, but it's essential for work. Versus FBSL 4, which would be your known outbreaks or high level of suspicion of a high-risk pathogen that you're dealing with, and all of the work that needs to be conducted to protect everyone, the training levels that people need to have to even be able to participate. Okay. The most confusing for people tends to be the personal protection. So I give this lecture and talk to various people within my field, so that way we could try to get more people piloting these new standards that we're trying to create. And the hardest thing for people to grasp is the personal protection, because it does not correlate well with the biosafety levels in laboratories. So we created a risk matrix. This is essentially a risk assessment that was where I was mentioning that we try to do in the previous chapters. But this is a simple risk assessment conducted purely based on your exposure, the level of exposure that you might have to a pathogen versus the risk of the pathogen that you're working with. And so here we pair the different methods that you might be exposed versus the FBSLs, which essentially is the risk of a pathogen that you're working with. So what this actually means is, with regards to the level of exposure, there are different things that we do in the field. So for instance, the almost certain uncontrollable risk is when you are maybe putting yourself in a situation where you just can't get away from exposure to a potential pathogen, whether that you're going into a cave and you're working under colonies of 1 million bats plus, and they're defecating all over you. There's no chance they're not going to defecate in your mouth if you don't have the protection. Or you're working under a colony of primates in the trees. There's maybe hundreds of monkeys up there, and they're defecating at random, and there's a high chance of you getting defecated on. Or working in a market where there's a high risk for avian influenza or known entities of avian influenza, and there's lots of waterfowl or various other poultry in the market that you just can't get away from the aerosols that are permeating the area. And then you have I put a whale here that is with a skull, which essentially means a mortality event for large animals that you're doing pathology or necropsies, and you're just guaranteed to have blood all over your body. Okay. Likely controlled. These are maybe smaller situations. You're conducting activities in a situation where the animal is anesthetized, or it is small enough to be easily restrained. Aerosol levels maybe aren't too crazy, and the animal is a small thing. You're just collecting samples, so no big deal. But you are directly handling that animal. But the risks to you would be respiratory, eye exposure, and then skin punctures. Then we have moderate, people collecting data that are within 2 meters of your animal work or environmental work, and they're essentially in the splash zone. They're going to have things splash onto their skin, and they're within the ability to contract things by respiration. And then further, greater than 2 meters. People who are runners, they're collecting all of your new supplies for you because you're too dirty, and so they have to stay clean. And then you have rare exposure, and these are people who are not participating in the project, but they are there to help. So they're your drivers, they're guards who are protecting the area, etc. Or community members that are just observing from afar because they're just quite interested. All right. So this is how we apply those PPE levels. And you can see here, we created, in addition to those FBSLs or those field biosafety levels, we created categories of PPE. And some of you may already know there are already categories of PPE developed by OSHA. And they have different levels because they're exposed to chemicals that people might be able to breathe in, toxins that might just corrode their actual PPE that they're working in. But this is purely about pathogens. And so we created these categories from 0 to 5, 0 being nothing, 0 being short sleeves, a t-shirt, shorts, and your own personal shoes, literally nothing, versus level 5 or category 5, which is all the way up to PAPRs. So the air purified PAPRs with positive pressure airflow all around your face, and Tyvek suits. Now, how do we pair that to the previous chart, the risk matrix that we made? You can see everything here is color coded. And let's start with field biosafety level 1. Again, as a reminder, this is like as if you're teaching students how to do research, or you're working with very low risk species, an octopus, or just fish, snakes, what have you. And so you can see, based on the level of exposure, the different activities that you have, from rare exposure all the way up to uncontrollable, we are guiding people on the different levels of PPE they should wear. And so you can see here, for people who really aren't participating and they're out of the splash zone, you wear nothing. There's nothing you need to be wearing. But all the way up to the almost certain and uncontrollable, what you have there is dedicated clothing. Clothing that you know is purely for the activities. And then when you're done with the activities, you take them off, throw into a bag and wash them. No big deal. The risk is still fairly low. And you can see plus or minus a mask, goggles, or safety glasses and gloves. Really, PI discretion based on the situation. Okay, moving on. You have FBSL2, which I won't, for me, for the work that we're doing, we liken this to working with livestock or low risk wildlife. So remember the animal risk groups that would fall under FBSL2 would be your mammals and your birds. Then all the way up to FBSL3, which is your higher risk group animals. So this is vector species like bats, rodents, and primates. We're recommending this level of PPE. And so you can see again, rare exposure, we're recommending, say, a driver, okay, hey, can you just wear dedicated clothing for the duration of this activities while we're out here in the field? Nothing more. We're not requiring them to wear masks or anything like that. But we are expecting them to stay out of the zone of concern. Whereas all the way up at the top, you can see people who are doing uncontrollable activities going into the caves or colony settings. They should be wearing their Tyvek suits. People who are doing the activities at hand, collecting the samples, we're having them wear sleeves, N95s, goggles, or safety glasses rather, and aprons. Okay. FBSL4, as I mentioned earlier, this is when you have a known situation. You know you have a high risk concern at your hand, whether you're dealing with an HPAI outbreak or Ebola or a very high risk for a coronavirus that you're concerned about. Then we go ahead and be wearing our PAPRs at the highest level or Tyvek suits at the controlled level. Okay, and even at the rare exposure, the people who are really not participating very much, they still also need to be wearing some level of protection while also being managed to stay out of the the high-risk zones. And the reason why we have them wearing this higher level of protection despite not directly participating is because there's a higher risk of them being exposed to someone else who has a higher exposure level. Say, for instance, someone accidentally touches somebody or interacts with them, or gets too close, or there's an emergency situation and they happen to just jump in and help out. We do want to ensure that they have some level of protection on hand. Okay. I do want to mention, before I move on here, is a reminder that while these standards are out there, they are only guideposts, a guidepost. We're not requiring anyone to follow these recommendations. They are simply recommendations based on the literature, based on the knowledge that's already out there that we know of. Should a PI, should a scientist, should anyone working with any of these animals decide they want to wear more or less, they are more than welcome to do so. But if you want to wear more or less, then you probably should be justifying this against what the manual is recommending. So that way you have an educated decision and everyone knows it. It's written down. It's submitted before your IACUC or your institution biosafety committee. And to the news, to the media that comes across the work that you're doing, you are justifying the reasons why you need to practice less or more biosafety. And it could be your personal experience, and that's fine. Or it could be, hey, the bats in Austin under a bridge have never been shown to carry any diseases of concern, and the risk of exposure is really minimal. Why do we need to be wearing PAPRs under here? So it's very important to be able to understand risk assessment is key to working with these recommendations that we're putting out here. Okay, risk mitigation protocols. This is the bread and butter with regards to how to, the specific guidance, SOPs on what can and should be done when we're working in these situations, how to apply your field biosafety levels. We give everyone lots of examples and we try to make it very easy to consume. This is an old setup. It does not look like this anymore. This was the very first draft, but this has been completely changed to make it much more digestible, palatable, user-friendly, so that way anyone who looks at this manual is not overwhelmed. And there's lots of pictures that people can be following, and there are lots of tables and quick guides. We don't expect anyone to be able to look at this book and read cover to cover. We really want people to be able to look at it as a reference book and open it and find the one area that they're looking for, read it and learn a bit, and then practice the safety that they need to follow thereafter. Okay. Also, we have directions on various levels of footpaths that people need to take depending on the biosafety level they're in. So this is just one example. Okay, this is emergency exposure and responses are going to be our second edition, and this, I mean, there are so many different materials written in the world that can be sourced, but our focus again is purely on pathogen risk. And so we really want people to know about, you know, if they're exposed to rabies, if they're exposed to Ebola, if they're exposed to any kind of risk that they don't know of, what they need to do and why. Okay. And then finally, we have our appendices, and that's going to be some quick reference guides, especially for people just to be able to print out and use as an easy method of practicing exactly what's in the book. All right, so this is just an example of some quick reference guides on the methods of PPE, depending on what it is that has been chosen based on their biosafety level. All right, so we are now in the process of getting a lot of our chapters peer reviewed. And you can see we have biosafety specialists, public health professionals. Those are our bread and butter because it's all about pathogen risk. But we also want and need people of the other disciplines that are also potentially subscribing to these biosafety levels and biosafety manual that's being put out there. Specifically biologists, ecologists, anyone, botanists even, that have a stake in what needs to be put out there. And we need to hear from everyone as to why something might not work, what is their perspective, what can be done, what have you done that has worked for you? And then hopefully we can incorporate everyone's ideas as best as we can to be able to provide the most robust recommended standards out there. So that way other entities like IACUCs and IBCs can use it as their reference guide. And the media who is concerned about the very things that we do can also reference it and say, oh, they are following what scientists around the world have all agreed upon as being safe for the work that's being conducted. In addition, there's a lot more that's going to be developed beyond this. It's not just the manual itself. The manual is the foundation for the work, but we're hoping that we are going to create many, many more resources out of it. Of course, it's pipe dreams, but eventually we do hope that this will come, including translations, as well as application resources for your phone. So people can very simply open their phone up and just type in, I am working with this species of bat in this area of the world in this season. What is my risk? And what is the field biosafety level I should be following? And what are the protocols and videos of those protocols, directions of these protocols that I should be using? And then hopefully we can get people from a level of zero protection or minimal protection to a standardized protection or minimal protection through and through that we're recommending. So this is my first time speaking specifically to a non-public health or One Health forum. And so I'm really excited to be able to share all of this with you, because the people who aren't directly focused on pathogen discovery are the people that I really have been looking for helping develop these protocols. So thank you.
Marc, thank you so much. Outstanding, man. I love this. Your audience is definitely chock full of people who are just these types of people in need of this knowledge. Basically, the membership of the Wildlife Society is basically full of people who do field work, whether it's management, whether it's research, et cetera, et cetera. And it really is relevant. It's a long time coming. Those of us who are wildlife veterinarians or wildlife biologists, there's never been any standard. It's usually fallen back to common sense and whether you've been reading your CE to keep up with what's going on out there. And that's not always an equal marriage of knowledge and application. So yeah, this is pretty exciting stuff, and I'm thrilled EcoHealth Alliance is putting this out. So with that, we've got at least one question in the open Q&A. I'm going to go ahead and read it. It's from Jay Fitzsimmons, and it says, thank you for developing this manual. Is there a way I can get an e-alert when it's published?
Yeah, great question. So we are very excited to be able to put this out there, and I will be perfectly honest. I have started this again as a small project, and then it developed into this massive thing. And I had intended on this being done in a 3 months time. And as it has grown, it has now taken me 3 years. The new deadline I have is for March, to have it finished by March, at least the first draft. And all during this time, there are various chapters that are being peer reviewed, so that way, people from CDC, specifically WHO, so they all have a stake. And WOA, of course, has a stake in the guidelines that are being put out there. And once the draft is finished, its peer review, then yes, we're going to be promoting this everywhere, because we did very much so want and are looking forward to the feedback for everyone in the field. In addition to just the manual itself, I have been piloting the recommendations of the manual throughout the world. So all across our products with EcoHealth and with our partners in the field, we're trying to get situations that are quite varied, cold wet situations, desert situations, humid, hot, different seasons, high rain, and trying to recognize that there are so many hazards and try to see whether or not there are more hazards out there that we need to be prepared for, and what is going to affect the ability for people to be able to contract the diseases of concern, and what levels of protection need to be put out there. In addition, by piloting these projects, we're also able to work with the various people on the ground who have different levels of experience, whether that's because they are scientists themselves, or have worked on big projects, or have no experience, but as a person living amongst these animals have developed their own levels of protection. We need to know, because we don't want to disregard anybody's experiences or thoughts, or priorities for that matter.
Outstanding. All right. Thank you, Mark. We've got another question from Cynthia Mosier. Is this manual going to be something that is also going to consider local health departments that handle rabies vectors to submit for testing?
Absolutely. So the hope and goal is to acknowledge everyone in the world. So whether that is US, any of the developed nations, or every developing nation, every nation that is trying to build their policies, we're trying to be able to provide guidance for them and also receive guidance from them. So we can ensure that everyone who's reading this manual has to recognize that they must follow their local regulations in addition to their product regulations, wherever they are in the world. We absolutely need to acknowledge various government entity input and requirements. So we don't want to override what a local government might want, but we do want to be able to provide what is conducted throughout the world. And sometimes, based on our history working with policy development with One Health work, the work that is created in a different country has not been created in country two, and they wind up adapting that because of the manuals that we put out.
Fantastic. So we got one more question, and after this, we may have time for one more, but this one's from Alyssa Bennett, and it says, "Thank you for sharing this impressive product and guidance." Agreed. Could you speak about the risk level for reverse zoonosis of pathogens? Specifically,
Yes.
how will the guidance address the potential for inadvertently establishing disease reservoirs in wildlife that could circle back to us in a more virulent form?
Excellent question. So that is a very, very perfect one. And so part of the FBSLs, the guidance that's put in there is to ensure that people are aware of the higher levels of risk working with different species, and the higher levels of disease from being transmitted to each other. And so, of course, we're protecting our very people that we're working with. And there are protocols for cleaning the tables and cleaning your instruments and ensuring that every bag that you use to capture a bat is sterilized between each bat. Sorry, I'm busy. Sorry, I'm in my hotel room. Housekeeping. Yes, but we also recognize that regardless of the biosafety level that we're practicing, there are diseases that are transmitted in between the animals. That is not a zoonotic risk at all. So yes, on one hand, we are trying to prevent our personal reverse zoonotic risk. On the other hand, we're also trying to prevent lateral risks between the species that we're working with, also interspecies disease risks. And so we're trying to provide some guidance on methods of decontamination that isn't necessarily about the biosafety level because of the risk to the human. It's really just the practices that need to be standardized in between animals and the decontamination that should be done within the individual projects. With that, though, the difference here would be you're working with a low-risk species that I've identified already. Let's say it's frogs, for instance. The level of decontamination that should be considered between each frog, honestly, should be the same level of decontamination that you use between each Ebola bat. And so we are writing this into the chapters as guidance for people to consider and to reference, but we also recognize that's a really big ask, especially if you're working at a very low biosafety level. But it needs to be said.
All right. So we've got another one here from Samara Trusso. And first, this is a great, and I'm looking forward to it. Maybe I missed it, but will this include recommendations and or at least risk assessments for parasites? I'm thinking of mange mites, giardia, etc.
Yes. So it's not just it's definitely not just about the emerging infectious diseases. It is also about all of your parasites, your endoparasites, your ectoparasites, your vector parasites, all of which are important here. We originally had not planned specifically to be touching arthropod vectors and then the protozoan parasites, but we realized it's as equally important as everything else. And so your decontamination methods are in there specifically to address the protozoans that won't be killed by the various other things that will kill your viruses. So we were trying to provide guidance on every material that needs to be used. And for instance, for the PPE, when we're working in caves, we're recommending people to be wearing Tyvek suits, but honestly, it's not enough if we're only looking to stop pathogens from getting into us, because there's bugs, and some of you may already know this, that are actively trying to get into the sides of our Tyvek suits and then cause havoc that way. And they may be carrying parasites within themselves. And so we have new recommendations on taping up your Tyvek suit, or only wearing PAPRs in those situations, because maybe the pathogen risk for emerging infectious disease is low, but the parasite or the ectoparasite risk is high. So yeah.
Right. So Marc, this is our last question, everybody. And it's again from Cynthia Mosier. You said you were interested in viewpoints from different professionals. How would someone be able to reach out?
Yes. So beforehand, we're trying to identify the leaders in each organization who are interested in providing input for our manual. But the bigger thing is we need to get this manual out as soon as possible. And so we're fully expecting edition 1 to be really bad, to require so much more input from all of the people who are doing this kind of work. So what we're expecting is a very quick turnaround from edition 1 to edition 2. I'd say even the amount of a year. But we're hoping happens is once edition 1 is put out there, that we publicize it, we ask for everyone to start implementing it, pilot it, use the manual, and try to implement it for your specific projects. And feedback, give us the feedback on whether it worked or not, or anything that you think could be changed or should be changed, or we should be mentioning. So yeah, that's how we're expecting to get the input from the various disciplines.
Outstanding. Marc, thank you so much. That was a fantastic presentation. And boy, do we need this, man. Those of us who've been doing field work for decades have kind of usually in the back of our mind, usually dreamt about something like this. And I know we gave a couple of shots at it with the Park Service, but it was on a much, much smaller scale. Anyway, thank you so much. And everybody who didn't get a chance to ask a question, we'll see if we can find a way to get those to Marc. If not, we'll wrap it up there. Thank you so much, everybody, for tuning in. And I hope it was helpful. I know it was for me. And with that, I will close it out. Thank you so much.
Thank you, John.